let's look at multiplying binomial radicals and multiplying conjugates. Remember, a binomial is a quantity that has two terms, and radicals simply have those radical symbols in them. So let's go ahead and look at an example. Example 1, let's take 2 plus the square root of 7 as one binomial, and multiply it to another binomial of 3 minus the square root of 7. Now, if these were variables, we go ahead and distribute the 2 and distribute the radical 7. Radicals, remember, act very similar to variables, and we can go ahead and do that as well. So we're going to distribute the 2 into our quantity. So 2 times 3 gives us 6, and 2 times the square root of negative 7. Remember, this is an outside number since there's no radical, or if you want the radical, we could put radical 1. Here, radical 7 is an inside number. Our outside number would be 1 since there's not a number denoted out there. So we have 2 times 1, which gives us 2, and then radical 1 times radical 7 gives us radical 7. To this, we're going to distribute this radical 7 through the second quantity. So radical 7 times 3, again, radical 7, that's an inside number, 3 is an outside, so we're just going to smash them together, and 3 times radical 7. And here we have radical 7 times negative radical 7. We're going to multiply those two numbers together and get the square root of 49. Now we can go ahead and simplify this. We can't do anything with the 6, but negative 2 radical 7 plus 3 radical 7. From our addition of radicals, our index is the same for each of our radicals, and the radicand is the same. So we can go ahead and combine these by adding the numbers in the front of each radical. And the square root of negative 49, we can simplify to 7. So our next line is going to look like 6 plus negative 2 plus 3 gives us 1. Remember, our index and our radicand is not going to change when we add radicals. And then the square root of negative 49 is negative 7. Now we can go ahead and take the 6 and combine it with this negative 7, and we'll end up with negative 1 plus the square root of 7. We cannot simplify this any farther since our radicals are different for each of these terms. So our final answer is negative 1 plus the square root of 7. Now in example 2, we're going to set it up slightly different, but we're going to do basically the same thing. Here we're going to take 2 minus the square root of 8, and we're going to square it. So there's a couple of things that we should see happening here. We can simplify the square root of 8, and we have this little 2 to work with. So let's go ahead and simplify that square root of 8 to start with. Remember, 8 is 4 times 2. So we take the square root of 4 and bring it out. So we have 2 minus 2 square root of 2. And this is to the second. A lot of 2's in there, isn't there? But remember that second just means that we have a second 1. So we have 2 minus 2 radical 2 again. And we just doubled the number of 2's that we had. But now our problem is going to look very similar to what we started with in example 1. So we can distribute the 2 to both of our terms in the second quantity, and the 2 radical 2 into each of our quantities. So multiplying the 2 first, 2 times 2 gives us 4. 2 times negative 2 radical 2 is negative 4 radical 2. And we're going to multiply the outside numbers together. This is only an outside number. And then we're going to distribute this negative 2 radical 2 in. So negative 2 times 2 gives us, again, negative 4 radical 2. And negative 2 radical 2 times negative 2 radical 2. Now we can go ahead and multiply the outside numbers together and get plus 4. And radical 2 times radical 2 is radical 4. Simplifying, we can add our two middle terms. So we have 4. Negative 4 minus 4 gives us negative 8 radical 2 plus 4 radical 4. This is a perfect square again, so it's going to go out and become 8 4 times 2 gives us the 8. Now we can go ahead and add 4 and 8 to give us 12 minus 8 radical 2. We cannot add these together since our first term doesn't have a radical with it. So there's our final answer. 12 minus the square root of 12 minus 8 square root of 2. Now in example 3, we're going to change it up slightly, just a little more. So we have 3 minus the square root of 128. And we're going to multiply that to 2 plus the square root of 32. Well, if we look at 128 and 32, those are large numbers, and eventually we'd have to multiply those two together. But what I like to do is to go ahead and simplify that as much as possible. 128 we can think of as 64 times 2. So we end up with the square root of 64, which is 8 radical 2. And in our second quantity, we can simplify that square root of 32. That's 16 times 2. So I have 2 plus 4 square roots of 2. Notice how much smaller my radicals become by taking out that perfect square. Now we can go ahead and distribute the 3 into our quantity, our second quantity, and negative radical 8 into our two quantities. So 3 times 2 gives us 6. 3 times 4 radical 2, 3 times 4 is our 12. Since we don't have a radical with this, our radical 2 just tags along. And then we're going to distribute the negative 8 radical 2. Negative 8 times 2 gives us negative 16 radical 2. And negative 8 radical 2 times 4 radical 2, negative 8 times 4 is negative 32. Radical 2 times radical 2 is radical 4. Now we're going to go ahead and simplify and clean it up as much as we can. Again, we should see that we have the same radicand and index for our two middle terms. So we have 6 minus 12 minus 16 gives us 4 radical 2 minus 32 times 2, the square root of 4 is 2, gives us 64. So if I take 6 minus 64, I end up with a negative 58 minus 4 radical 2. Can I combine those two? So there's our final answer. Negative 58 minus 4 radical 2. Now in our final example, example 4, we're going to go ahead and talk about what the conjugate is and what conjugates do. And really conjugates are kind of special quantities to each other. They have a special relationship. And once we look at this, hopefully we see what the conjugate is. And we've worked with conjugates even though we didn't call them conjugates. So here, if we look, our two quantities are almost identical to each other. But we have a 1 minus and 1 plus. If you remember back in factoring, when we took x squared minus y squared, and we factored that, that factored to x minus y and x plus y. This gave us two conjugates. Basically what a conjugate is that we have the same terms, they only differ by the sign of the second term. Here we have a minus, here we have a plus. Here we have a minus, and here we have the plus. So notice when we multiply two conjugates together, we end up with two terms here. Remember that middle term always canceled out for us when we were factoring. So let's go ahead and look at what happens with radicals and two conjugates of radicals. Here, if I take square root of 2 and distribute it to my second quantity, I get the square root of 4. Radical 2 times 3 radical 3. Here I'm going to multiply my 1, which is my outside number, to 3. Radical 2 to radical 3 gives me radical 6. Minus, I'm going to distribute my 3 radical 3 to radical 2. Again, outside to outside, inside to inside numbers. So I get minus 3 radical 6. And negative 3 radical 3 times positive 3 radical 3 gives me negative 9 radical 9. if I clean this up, I know the square root of 4 gives me 2. 3 radical 6 and negative 3 radical 6, I can combine those since they have the same radicand and the same index. They're going to cancel each other out. 3 minus 3 gives me 0, and 0 times radical 6 is still 0. And then over here, the square root of 9, which is 3, times 3 gives me 27. So now I have 2 minus 27, which gives me negative 25. And there's our final answer. Conjugates are going to become very important to us in our next lesson, in which we rationalize radicals. But the thing I want you to see here is that we call these conjugates because each of the terms are the same. We only differ 1 minus and 1 plus. And that concludes our multiplying binomial radicals and multiplying conjugates.